All right, so this is Stats XL10. Okay, introductory statistics. Okay, and I love this class. I love teaching this class. This is when I took introductory statistics as an undergraduate student, it literally changed my life. I was a engineering major at the time. I finished my bachelor's degree in engineering, but after taking my intro stats class, I fell in love with the subject. I took more statistics classes, and then after graduating, I worked for a few years, and then decided I wanted to come back to graduate school to study statistics. So I came back here to UCLA, and I got my master's and PhD in statistics, and here I am. This is my dream job to now teach statistics to you guys. So yeah, exactly. So I'm very happy to be here, and I know for many of you, you might not have shared my enthusiasm for taking statistics, but I'm hoping that by the end of the course, you will at least gain an appreciation for the subject and maybe see its usefulness and relevance in the larger scheme of things. I know many of you are coming in kind of feeling like you are not a math person, and that's okay. You do need a command of some basic math concepts like algebra and arithmetic and all of that, but statistics is very different from other math disciplines, okay, and it requires a bit of thinking about our data and what that means and the contexts from which they come. So anyway, I'll write I heart statistics. Okay, and I hope you guys enjoy the course as well. So with that, we shall get started. Okay. All right. Well, and if you'll indulge me just as I go on in my little spiels here, I know for some of you this class also represents, just this hurdle that you need to overcome to maybe continue on in your academic progress and things like that, and for some of you, this class will be easy and you can get through it, no problems. And for others of you, this class will be a struggle, okay? And I want you to know that there's no shame in working really hard and failing, okay? I know it's never what we want. We never want to actually fail, but there's no shame in working really hard and failing, because that's going to happen no matter what discipline you pursue in life, or anything that's a challenge that could definitely happen. And so if this class represents that hurdle, do your best, work as hard as you can. I will do what I believe to be my part in providing you with all of the resources you need to study and prepare for in the exams, and you do your part in working hard. And I hope all of you guys do well, and I hope all of you guys pass. But again, there's no shame in working hard and failing. Okay, that's definitely happened to me in my life, and sometimes it delays things in life, and it maybe causes you to take a little bit longer to reach the goals that you want. But you just you want to be proud of the journey you take. So anyway, just wanted to throw that out there. Okay, let's get started, and we will say. So I think anytime you take a course, one of the first questions you should ask is, why do we bother taking this class, right? So why do we study statistics? Okay. Oops. And so I know for some of you it might be just because the school said you had to. Um, but why would the school say you should take statistics? Okay, well, I argue that statistics helps us understand the world around us. Okay, and this could be said about many subjects offered for study. Okay, so a lot of the sciences are about understanding the world, but even subjects like history, we gain an understanding of the world through historic events and things like that. In particular, what statistics allows us to do, so I'll say in particular, allows us to make conclusions from limited data. Okay, so let's talk about what it means to make conclusions from limited data. Okay, and I think at this point I should just check in, make sure all of you guys can see the board clearly and read when I'm writing up there. Is that correct? We're good? Okay, so I got thumbs up from the back of the class, and that's a good sign. Okay. Okay, and then sometimes I'll ask questions like, does that make sense, or is that okay? And if you guys can just smile and nod your head, then I know we're in good shape. Okay, and it's always nice to see all of your smiles too. So I'll try to smile at you guys, and if you guys can return the favor. Okay. All right. So anyway, okay. So in particular, I said statistics allows us to make conclusions from limited data. So what do we mean by that? Okay, so when we do science, okay, whatever we mean by science, sometimes we often begin with a research question. Okay, so we begin kind of scientific studies with a research question. Now, our research question could be, any sort of thing, right? Like, does, I don't know. So we might ask a question like, does a new experimental drug help, we'll say, lung cancer patients help lung cancer patients improve more than currently existing treatments. All right. So this is a question. Does some new drug is this better at helping lung cancer patients than whatever it currently exists out there right now? To answer this question, the only way we would know the true answer to this question is if we were able to study everyone that is relevant to this question, okay? And so we have something called the population. Okay? So the population, this represents everyone. This is everyone who is relevant to answering our research question. Okay, and when I say is relevant to answering our research question, I'm not talking about the doctors, okay? I'm talking about just the people that were interested in, in kind of applying the treatments and stuff. So who is the population in this example? Lung cancer patients, and it would be all lung cancer patients, okay? So the population would be all lung cancer patients. Okay? And so, there might be millions of lung cancer patients, I don't know. It's going to be a very big number. And so, to see if this new drug truly is more effective than currently existing treatments, we would need to set up some kind of experiment that involves everyone, and this just is not going to be practically possible. So we're going to write, the problem is that the population is too big for us to study directly. Okay. All right, and so instead of studying the population, we study a sample, okay? So because the population is too big, okay, we will observe and study a sample. And a sample is a smaller group taken from the population. Okay, so let me draw a little picture here. So this is our population. It's this big thing. It's too big for us to observe directly. And so what we're going to do is we're going to just take a little piece out of it, okay? And we're going to magnify this piece. Okay, and that's the sample, okay? And we're going to, we observe and study the sample. Okay, and based on what we see in the sample, we try to make conclusions about the population. Okay, so I'm going to draw a little dotted line. And so that process of making conclusions about the population, this is called statistical inference. All right, and that's what I mean by we try to make conclusions from limited data. So even though we can't study the population directly, we can take a little chunk out of it. We can study this sample. And then we perform the process of statistical inference. And based on statistical inference, we make conclusions about the population. Okay. All right, and so the types of conclusions that we can make is are things like, yes, the sample, the data that I've observed. Okay, so we can say something like, the data I've observed from my sample provides evidence that blah, 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 okay? So perhaps our data gives us reason to believe that something is the case about our population. And other times, because for one reason or another, the sample just might not be enough information for us to make a meaningful conclusion, okay? Or we can say, we do not have enough, and I'm going to just put enough in the parentheses, enough evidence to conclude or to make conclusions, I'll just say we do not have enough evidence to conclude something about the population. Okay, and that's certainly another possibility. Okay, so you could gather data and it still might not be enough for you to make a meaningful conclusion. Okay. Okay, and so, in general, if we want the conclusions that we make about the population to be valid, okay? So remember, the conclusions are based on a sample, right? So if we want the conclusions that we make about the population to be valid, even though we're using just a sample, okay, then our sample needs to be representative of the population. Okay, and so representative means that the sample looks like the population, okay? Okay, representative means that the sample looks like the population. So, you have to, so this is something to watch out for, okay? A lot of times, you know, scientific studies have kind of come under a lot of fire because sometimes people seem to make outrageous claims, you know, based on the study. You'll say, like, this study shows that eating tomatoes prevents cancer, and then another study says, oh, you eat tomatoes, it's going to cause cancer, and or you know, things like that. And it's like, well, how do we make sense of all of this? Okay, and so science in general is a hard thing to do, and a lot of it is based on, we're looking at a sample, and based on the sample, we're trying to make a conclusion about the population, okay? And so maybe in one particular group, we gave them tomatoes and it seemed to either increase or decrease the risk of cancer for this particular thing. And if you delve down into the study, maybe it was done fine, maybe there were no problems, or there could be problems, okay? Sometimes studies are done on rats, okay? And when you look at what happens to rats, it may or may not be representative of what happens in humans, okay? And so there's a question of, are the results that happen to rats, are they representative of what would happen to humans? And that's a tough question to answer, right? So representative means that the sample looks like the population. Sometimes our samples look like the population, sometimes they don't. So, you know, if you're testing on rats, does that look like the population? Not really, okay? If you're doing surveys, okay? If we asked, you know, who are you going to vote for in November, okay? If we surveyed people in Los Angeles, the answer to that is not going to necessarily represent what the country as a whole, how the country as a whole will vote, okay? Or if we surveyed people in Texas and we asked, how are you going to vote in November? The responses that we get in Texas may or may not look like the responses that for the country as a whole, okay? And so trying to get representative samples is important, but also challenging to do, okay? So representative means that the samples look like the population. If the sample does not look like the population, okay, we say that the sample is biased. Okay, and so we'll say one method that should give us representative samples okay, but you know, it's not guaranteed to do so. Is called simple random sampling. Okay, or we might abbreviate this SRS, okay? And so the way simple random sampling works is we begin with a sampling frame. Okay, and ideally the sampling frame is a list of everyone in the population. okay? And so this is actually a difficult thing to do. If I were to give you a homework assignment that said, get a simple random sample of people in Los Angeles, okay? You would need to start off with a sampling frame, and you would need a list of everyone in Los Angeles, okay? Now, what could you possibly use for a sampling frame? See, what could you possibly use for a list of everyone in Los Angeles? Okay, so a phone book, all right, maybe, but is anyone here listed in the phone book? Okay, so this is not going to be a good sampling frame because it's going to be missing pretty much anybody who's not in the phone book, which is looking more and more to be like a lot of people, okay? Census information, that's, you know, if the government were to release that information to us, we might be able to have it, but that information came from 2010. It's already 6 years old. I'm sure many of you moved to Los Angeles in the past 6 years, and a lot of people moved away or were born or have died, or who knows, all sorts of things can happen in 6 years, okay? Some of you were still in middle school. You know, a lot happens in 6 years, so census information may or may not be good. I'm trying to think more modern ways to get a good sampling frame. If Facebook were to share their information with us, we might be able to get a list of everyone who has logged on to their Facebook account from an IP address located in LA, but that's going to miss a lot of people who don't log on to Facebook. Probably the best method I can think of, but maybe practically is not possible if because we don't have this kind of access, is we might be able to access cell tower information and see whose phones have pinged a cell tower within the city of Los Angeles, and that's only going to get people who have cell phones, but a lot of people have cell phones these days. Only a small percentage do not. But yeah, you know, that would require access to the cell tower infrastructure, which you and I as common people probably do not. Perhaps the government does, or perhaps the cell companies do. Yes?
So on government ID, it shows the height or the weight, so there's a record for everybody who lives in LA,
That,
or in California actually.
so, you know, government IDs?
Yeah.
But that's only, yeah, again,
DMV, but
yeah, but I don't know. I mean, is the address that is the DMV has on file for you, is that up to date for everyone here? Probably not, right? Especially young people who move around quite a bit. Probably the address on your driver's license is not current. Okay, so these are very difficult things to do. So from a practical standpoint, you can see that this is quite a challenge to pull off. And so there's all sorts of, so, you know, doing a simple random sampling for even something like the city of Los Angeles is very challenging to do on a practical level. You have organizations like Pew Research and in different places that try to get as close to a representative sample as they can, because the purpose of their company is, you know, to get opinion polls of generally Americans, you know, like what percentage of Americans support this proposed legislation, and they're trying to get a survey that represents how America as a whole feels, but that's a tough thing to do, okay? So anyway, that's but let's say you could get a sampling frame. So, you know, if we're talking about like a school, you can get a list of all students enrolled in the school. That's okay, okay? Ideally, the sampling frame is a list of everyone in the population, and then using a random device, Okay, and this could be a computer that generates random numbers, or you could put everyone's name on a piece of paper and throw them into a hat and shake it up or something. Using a random device, we pick people from the list one by one, okay? Okay, don't just close your eyes and say, I'm going to pick this person, and then I'm going to go around and pick this person, because that is not random. That's going to, that's arbitrary, but arbitrary is not random. So people are notoriously bad for picking random things at random, okay? So use a random device to pick people from the list one by one, okay? And what this will, the results are every person in the list, so every person in the sampling frame has an equal chance of being selected. And every possible sample has an equal chance of being selected also. Okay, and so what do we mean by every possible sample has an equal chance of selection? You can kind of think of lotto numbers as a simple random sample. They've got a machine with a bunch of ping pong balls in there, and they bounce around, and they just pick numbers one at a time from this machine that bounces the ping pong balls around, okay? And so that's effectively a simple random sample. And so, every possible combination of numbers, whether it's, 3, 15, 25, 32, 37, 44, 46, that has the same probability as picking the numbers 1, 2, 3, 4, 5, 6, or however many numbers appear on the lotto ticket these days. So, every possible combination has an equal chance of being selected. So, so that's one of the results of simple random sampling. It should give us a representative sample, but is not guaranteed to do so. Okay, let's see. It's 8:20. Why don't we take a short break here? We'll come back at 8:30 and we'll finish out our class.